You've seen the photos, you know the story of the moon landing, but what if I told you the entire mission came within seconds of a catastrophic failure, just moments from touchdown? Well, this is the untold story of the software and the incredible woman who saved Apollo 11.
So I want you to picture it. You're inside the lunar module, the Eagle. You can see the moon's surface rushing up to meet you. The whole planet is watching, literally holding its breath. The stakes couldn't be higher.
The date is July 20th, 1969, and humanity is just 3 minutes away from its single greatest achievement, landing a person on the moon. Everything, and I mean everything, is on the line.
And then, out of nowhere, the calm is just shattered. Alarms start flashing on the display. 1202, 1202, what does that even mean? Error messages are flooding the cockpit, the computer is completely overloaded, and mission control is about to call an abort.
I mean, can you imagine? After all those years of work, a 250,000-mile journey, was it all going to end right here, just a few feet from the lunar surface? The answer to that question, believe it or not, was written years earlier by a programmer who saw a failure coming that nobody else thought was even possible.
To understand how they got out of this mess, we have to rewind. We've got to meet Margaret Hamilton. She was the lead software developer for the entire Apollo program, at a time when computer programming was basically the Wild West, a brand new frontier.
You know, when Hamilton started at MIT, the word software wasn't even really a thing yet. The whole idea that you could write a set of instructions that let a machine do a bunch of different things on its own, well, that was revolutionary. And she saw its potential right away. And what a project to get started on, right? The Apollo program had 2 of the world's first ever portable computers. One for the command module to get them to the moon and back, and then there was the Eagle, the guidance computer that was absolutely crucial for the landing itself. And Margaret was hired to lead the team that would program these amazing machines.
Now, this is where the story gets really interesting. The key to saving Apollo 11 wasn't discovered in some sterile lab. Nope, it came from a little accident at home that revealed a huge, prophetic flaw in the whole system. So get this. One day, Hamilton's young daughter Lauren was visiting the lab, and like any kid, she starts playing around with the mission simulator. She pushes a button she's not supposed to, and accidentally kicks off a pre-launch program while the simulator was supposed to be in the middle of a flight. The result? A total system crash. All the navigation data just gone. A simple mistake that led to a complete simulated mission failure.
Hamilton, seeing this, immediately raised the alarm. She said, "Hey, we need to build some error checking into the software to prevent this." But the higher-ups were pretty dismissive. Their thinking was, come on, our astronauts are the best of the best. They're too well trained to make a silly mistake like that. Well, then came Apollo 8, and reality hit hard.
During the Apollo 8 mission, an astronaut did the exact same thing Lauren did. He pressed the wrong button, and poof, the navigation data was wiped clean. They were literally lost in space. It took Margaret and her team 9 agonizing hours to recalculate everything and upload new data just to get them home safely. Her warning had become a terrifying reality.
Okay, so let's jump back to Apollo 11. We're 3 minutes from landing, alarms are blaring. But this time, because of that hard lesson learned on Apollo 8, Margaret Hamilton's software was ready for a fight. That 1202 alarm meant one thing. The computer was trying to do way too many things at once. It was getting swamped with tasks, its processing power was being pushed to the brink, and that was putting the all-important landing calculations in serious jeopardy.
So, inside that computer's memory, a battle was raging. You had the absolutely critical jobs, like processing landing data and calculating trajectory, competing for resources with much lower priority stuff, like running the rendezvous radar, which they didn't even need for the landing.
And this, right here, is the genius of her design. Hamilton had built a system that could prioritize. It was smart. Her code automatically detected the overload, looked at all the tasks it was being asked to do, and basically said, nope, this stuff isn't important right now, we're landing. It just dropped the non-essential tasks to focus on the one and only thing that mattered, getting that Eagle on the ground safely. The Eagle landed, a triumph for humanity. But the legacy of Margaret Hamilton's work didn't just end on the moon. It went on to shape our entire modern world in ways you can't even imagine.
The mission's success gave this new field of computer programming a ton of credibility. In fact, Hamilton herself coined the term software engineering because she wanted to argue that building software required the same respect and the same discipline as any other field of engineering.
And what makes all this even more astounding is the tech they were working with. The entire Apollo guidance computer, with all of that revolutionary, life-saving code, ran on just 72 kilobytes of memory.
Now, to put that in perspective for you, that's just wild. A single, simple email you send today is about 300 kilobytes, 4 times bigger. A single photo from your smartphone, that's over 4,000 kilobytes. They landed on the moon with a tiny, tiny fraction of the memory it takes to send a picture of your dog. Incredible.
And they packed so much into that tiny space. It wasn't just the landing software. The Apollo computer had the first ever fully computerized navigation system on a spacecraft. We're talking groundbreaking autopilot technology. It was really the birth of the digital age, happening right there in that little box.
Margaret Hamilton software was the ultimate safety net. It was this invisible layer of logic that worked perfectly under the most extreme pressure imaginable. It really makes you wonder, doesn't it? What invisible code, built on the very principles she pioneered, is running in the background of our lives right now, quietly keeping us safe and making the impossible possible?